In this section of the course, we're going to talk about application security controls. So we're going to concentrate on applications first, and in this unit we'll cover some other topics as well. But let's start with application security. We've already talked at this point about some of the vulnerabilities that exist in applications. Now we're going to talk about how to protect ourselves from those vulnerabilities. One of the first ways that we can protect ourselves with applications is ensure that we're using secure coding concepts. So in your textbook, they talk a little bit about the software development lifecycle, or the SDLC. You may have also discussed the SDLC in other courses. I'm sure it comes up in many of the courses that you take in this program. And there's 4 basic steps in the software development lifecycle. You begin with an analysis, then you do your design, your implementation, and then finally testing. So with systems analysis and design, you start by trying to learn about what it is you're trying to develop. That's your analysis phase. And then in the design phase, you're actually designing this new system. In implementation, you're actually coding the new system, and then finally testing. I've highlighted testing here because from an IT security perspective, testing is a very important step to making sure that we have secure applications. There's a lot of things that we can do in the testing phase, and as IT security professionals, we can bring some perspective to the to the testing as far as how to test applications to make sure they're not vulnerable to some of the attacks that we're talking about in this unit. So one of those things we can do is make sure we're using input validation in applications, and we can test that, of course. We can look at error and exception handling and make sure that they're, with the error and exception handling, that it's not returning too much detail that an attacker could use in reconnaissance. And we talked previously about Crosssite Scripting and how dangerous Crosssite Scripting can be, and we can make sure that we have protections in place that can mitigate those threats against Crosssite Scripting. And then finally, make sure we do testing and application hardening, which I'm going to talk about in this presentation. So first, let's talk about error and exception handling. So vulnerabilities in software represent a common attack vector. So this is the obviously at the end of the day, the attacker is really going to be going after applications. They have to get through networks to get there. They have to get through hardware and host and operating systems and things like that. And those things we also cover in this course. But in the application, obviously that's one of the main attack vectors for an attacker to try to get access to data. So, and I think we've talked about this, the steps that an attacker would take to attack anything, whether it's networks or software or hardware, the physical plant, it doesn't matter. The first step is reconnaissance. It's finding information. And errors can provide a lot of useful information to an attacker. When we talked about, say, a SQL injection attack, if an attacker is trying to figure out what the table names are and what the field names are, error messages can reveal some of that information. Error messages can sometimes even reveal exactly what database engine you're using and what version it's running. Same with the with the error messages that get returned by the web server. If you're running Apache versus IIS, the error messages that are standard could look very similar for all the IIS versions, and likewise for Apache. So you can kind of discern which of those your target is running. So one thing is log files is a better way to handle that useful information that we would need for debugging. So, obviously having error messages is important because we need that for debugging and finding out what went wrong, but it's more appropriate for that to be in log files than for displaying it to the user. So rather than giving the user all this detailed information about, about what went wrong, we should put it in the log files. I was actually just using a system the other day for another school that I teach at, where the grading system, when you go get an error page, it actually reveals all of the information about the table and the columns for the database. It's an Oracle database, and you can tell from the error message, and it gives you all the information. It actually shows you the SQL statement that it tried to run if it got an error message with SQL. And when I was using the system, I could see that that it didn't interpret an apostrophe or something like that. So I was able to actually fix the problem myself, which is great, but an attacker would be able, that's a treasure trove of information for an attacker. They could craft an interesting attack if they know exactly what type of database and what the table names are and the fields and so forth and so on. So don't display detailed error messages to the users. Instead, put them in log files, and if you want to have those detailed messages, maybe have some kind of a debug mode that you can put the software in. So as far as error handling, this is another concern. Is one way you could do error handling is through function-based error handling, which evaluates the return. So, in other words, within a function, you might have error handling that sends a return back. But a better way to do error handling for programming is using structured try-catch. So try-catch around methods in programming is a little bit better than having function-based error handling for a variety of reasons. It certainly helps streamline the error handling, that's for sure. And then fail-safe data in transit and ephemeral data. And what your book is referring to here for data in transit and ephemeral data in transit is application data that's being transmitted between either instances of an application or over a network. And ephemeral data is data that's in memory, which is kind of interesting. I guess there's two senses of the term ephemeral. There's ephemeral data could refer to data that's in memory, but it can also refer to data that's temporarily stored on a device that maybe you didn't intend to store there. We talked about locally shared objects before, and that would be an example of, kind of an example of ephemeral data. And in some contexts, that is ephemeral data. But ephemeral, what we're talking about, is data that has a short lifespan that lives somewhere that you wouldn't expect it to be there, and an attacker could take advantage of that. Memory is kind of the perfect example of that. And then there's noise, which your book talks about. So input validation is a technique. So we've talked about SQL injection. I talked about cross-site scripting and path traversal. There's also this thing called canonicalization attacks, which deals with using different encoding mechanisms to inject malicious code. So sometimes you can sidestep, and really one of the main mitigation techniques we have for all these attacks is validating input. In other words, making sure that input doesn't have certain things in it, like it doesn't have code, or it doesn't have HTML or JavaScript, or there's no SQL code in there. We're escaping any SQL characters that are special characters and so forth. But one way you can get around that is by using different encoding schemas. So if you send data to the server, if you submit data using a different encoding, when the server interprets that, it could interpret it as the characters that would initiate that attack. But our front end input validation may not catch that it's using a different encoding mechanism, and it sees just a bunch of gibberish for the characters because it's reading as a different character set. If you want to learn more about this, you can take a look at RFC 2279, which explains this in a little bit more detail. So the bottom line here is we want to consider all input to be hostile. We don't want to trust anyone. Even if you're designing an application that's only used by trusted users or something like that, we still want to make sure that we're using input validation and that we don't trust anyone who's providing any input. So we want to sanitize all the input, verify the encoding, removing any illegal characters, and sometimes it's even a good idea to just whitelist acceptable values. And I'll give you an example of that. If you've got a field for, say, the state, there's only, first of all, there should only be 2 characters. And second of all, you could actually validate against a whitelist. There's no reason anybody should be putting anything in that's not a valid state, unless it's an international application, then maybe there's some other context, but you could actually even whitelist, whatever you expect. So if you have some expected value, you can whitelist for what you're expecting to see in that field. Now, if all else fails, we also have fuzz testing available in our toolbox, and this is a relatively new phenomenon in testing. Basically, the concept of fuzz testing is that you don't know what you don't know. It's nearly impossible to test every possible thing that an attacker could submit to your server to try to pull off one of these attacks that we've talked about. So fuzzing is a way of systematically providing random data as input. And then you're watching for exceptions or crashes that you can analyze to find what the flaw is. So you're basically, fuzzing is basically programs that you can use that will systematically submit random data. And the idea is that random data it may make it easier for you to detect things like memory leaks or buffer overflows, some of the other attacks that we talked about previously. So if we submit a bunch of random data, we might be able to detect those memory leaks and buffer overflows and things like that, by just putting in data that we never would expect. So fuzz testing, like I said, it's a relatively new technique, but it is a powerful technique because there really is no way to test everything that attackers are going to try. Now, that's not to say that fuzz testing catches everything, because it doesn't. But it's certainly one more tool in our toolbox that we can use to try to break whatever it is we're testing. And by watching how it fails, we can learn more about what an attacker might try. So it is an important technique. Crosssite scripting, I think we've talked about it before, and we know that this is a pretty common attack vector, and we know that we have to protect against it. And what we discussed before about Crosssite scripting is that there's two types of attacks. There was non-persistent and persistent, and both of those attacks are typically DOM-based attacks, meaning, and I didn't talk about this before, but DOM is the document object model, and it's usually used with JavaScript, and it's how you can manipulate different elements in HTML. So JavaScript allows you to manipulate elements in HTML using the document object model. So from anywhere on a web page, for example, you can use JavaScript to reference different HTML elements or HTML5 elements and change them dynamically. And this is one of the things that, this is the way that, using the DOM is how a lot of these modern web applications work, like Facebook and Twitter and so forth and so on. A lot of these things that you use every day, they're using the DOM to do a lot of the fancy dynamic manipulation of the client side in the web browser using things like Ajax and so forth. So cross-site scripting attacks might be using this to steal authentication information, hijack sessions, deploy hostile content through websites, change settings. They might be used for phishing attacks and so forth. And again, we kind of talked about some of the different techniques that that hackers typically employ to try to carry out these cross-site scripting attacks. Some of the ways that we can protect it, probably the most common is to use one of the cross-site scripting libraries. The thing about libraries that's nice is somebody's already figured out a lot of the ways to protect against these things, and you can update those libraries, and when you update them, they protect you from a lot of the newer techniques. The downside is sometimes it makes it harder for us to understand exactly what we're doing to try to protect those attacks, and we don't know exactly how we're vulnerable. But it's certainly a good place to start. If you're not going to do anything, or if you're going to do nothing else, then these libraries are probably the easiest thing you could do or ask your programmers to use. We can also limit the types and sizes of inputs and uploaded files. We can use whitelisting, a lot of very similar techniques when we talked about input validation. So it's sort of the next step in input validation. And really, it's kind of a lot of this is really the same as input validation. All right, so a cross-site request forgery is exploits a site's trust with authenticated users. So the idea is that, and your book has a nice example of a bank, but the basic idea is that a user is authenticated, say, to the bank's website, and you can take advantage of that to carry out some kind of an attack. And like I said, your book has a good example of that. But some of the techniques are we can limit the authentication times, or how long people are authenticated. We can expire cookies. We can check headers. And I think in the lab I actually ask you to try to change headers. And that's kind of the lab that you do is somewhat of an example of forging authentication. I think in the lab you're actually changing the header so that you appear to be coming from a different, your URL that you linked from is coming from a different site than it actually came from. And so that's kind of a good starting point for cross-site request forgery. And I think your book actually talks about that in the example. But anyway, this is some different techniques that you can use to mitigate those attacks. All right, so we can harden applications. We're going to use that term again, or in other sections we use that term, application hardening. So we use the same principles as system hardening. If you're familiar with system hardening, There's some techniques we can use to harden systems. In some of the other videos I do talk about that. But for application hardening, basically we're going to try to remove any unnecessary components. Anything we don't need in that application is disabled. We make sure the application is configured properly. We make sure it has all of its updates and patches. So these are some of the basic application hardening techniques. The other thing we want to do is we can do an application configuration baseline. So basically what we do is we identify what the correct settings are for applications and we document those. So we're documenting the correct settings for applications. So some of the techniques is we can look at applications and security settings, access control, look at the documentation, and try to determine what the correct settings are in our environment, and we document those. And once we have a baseline, we can make sure or we can check if anyone strays from that baseline. There's automated tools to do this. You can always go back to that baseline if you're rebuilding something, but it's certainly a good technique. And along with that, we do want to make sure we're on the latest patches, so patch management is important to make sure we're running the most secure and recent version of any application. So there could be a formal process that we can establish to ensure application of patches. Microsoft Windows, for example, if you're using Active Directory, there's some patch management features in Active Directory, although sometimes it's difficult to implement those for applications that are not in the Microsoft ecosystem. So there are other patch management applications and servers and things like that out there that you can look into. And most organizations have some kind of patch management system. If you don't, you would drive yourself crazy going out and doing patches. The thing about patch management is vendors have to cooperate with other vendors to make sure that you can detect that patches are needed. So the thing is, if you have applications that are critical to the organization, you might want to make sure that it's compatible with your patch management system. And if it's not, you may have to have some other process to make sure that they're always updated and patched. We did talk about SQL before, and input validation, of course, is going to help us with these with these attacks on SQL. And I think for the most part, most of you probably have taken a database class. If you haven't already, maybe you will in the future. It's one of those classes that just about every program in an IT school or a computer science program requires you to take. So the thing about SQL is that it's very well understood, but there's also NoSQL, which is the relational databases. Which are great. They're really powerful, these new relational database systems. I say new, but they've been out now for 5-10 years, some of them. But the thing is, for IT security people, I think relational database systems are kind of an enigma sometimes, and it's important to be aware that these NoSQL type databases exist, and it presents a new vector of attack. So we want to make sure we try to understand it if we have it in our organization, that we make sure we try to understand how it works. And in many cases, the syntax for NoSQL is basically the same as SQL, but there may be other types of attacks for which it may be susceptible to. So we would certainly want to discuss that with our vendors and make sure we understand how to protect ourselves from cross-site scripting attacks with the NoSQL variety of databases. And finally, as far as validation goes, there's two techniques for validation. There's server-side and client-side validation. So form validation can occur on either the client or the server side. So typically client-side validation is done using JavaScript, and server-side validation could be used by some kind of server-side scripting language. Some examples of those might be PHP, ASP.NET, Java, Ruby, Node.js, etc. And you may recognize some of these as the underlying server-side language that's used by some web application that maybe you work with. But we have two options. We can use validation in one of those languages on the server side, and we can also use it on the client side. Most security experts recommend doing the validation on both sides, on both the client side and the server side. And you might be asking yourself, isn't that kind of redundant to do it on both sides? If I do it on just the server side, doesn't that cover me? Or on just the client side? The first thing to realize is that the client side really can't be trusted, because the client side is JavaScript that's rendered in the browser. The browser basically consumes JavaScript and executes that code, but there's nothing that stops an attacker from bypassing that JavaScript. They could make their own version of that web page that doesn't have that validation code, and they can submit whatever they want to a website. You don't necessarily have to submit to a website through the form that the website gives you. You can make your own form and submit to a website and post anything you want and completely bypass that form validation. So in that sense, it's always better to do server-side validation. But if we do the server-side validation, it's generally best if we if we try to validate the best we can on the client side as well. Even though somebody may bypass that client side validation, our server side should still be able to catch it, but we can maybe not even get that far for the casual attacker by doing JavaScript for the client side validation. So again, it's best to use both of those. So all validation should be done on the server side, but we can also redundantly do it on the client side just to prevent data from even getting that far when it doesn't have to. So it's just one less vector of attack, I could say. One thing we do have to be careful though with the client side that I want to mention, it's not in the slides, but I do want to mention is that, again, one of the things that attackers are going to do is they're going to do some reconnaissance. And in that reconnaissance, they're going to be looking at, JavaScript to try to see if they can discern anything from that JavaScript about the server side. So they're going to look for clues about SQL fields. They're going to look for clues about what database engine you're using, any kind of libraries that you might be using to prevent, say, a cross-site scripting attack, so they know what the vulnerabilities might be. And some of that stuff, there could be some important hints for the attacker in the JavaScript on the client side. So we want to make sure that we obfuscate things in that JavaScript on the client side. For example, don't use the field names that are the same as your database field names. Maybe come up with some other vernacular or some other naming convention to display on the client side and map it on the server side. Okay, so that's some of the techniques for application security.